All right, let's get started. Hello, everyone. First of all, thank you so much for staying until the last session of the Build conference. I suggest we should give a round of applause to ourselves to staying this late, okay? So my name is Ming Fei, and I work in Azure Media Services as a program manager. And this session is about Azure Media Services Developer Deep Dive. And we are going to talk a lot about how to build a media services solution. Of course, the evaluation. Remember to submit the eval. If you really like the session, do use the app and submit. If you really don't like the session, come and talk to me after the session. And this is today's agenda. First of all, we'll talk about what is Azure Media Services. And then we'll go into detail about video on demand workflow. We'll talk about the color in the title in blue are something pretty new. Some of the cool encoding feature we added, dynamic packaging, media intelligence. And then we will talk about Azure Media Player, how you could build a player from scratch using Visual Studio. And content protection. If you want to put protection over your stream, how you can do it with AES and DRM. And then we'll talk about live encoding and streaming workflow. How does it work? And I will show you guys demo how you can get started from scratch to live stream and live encode this session and generate content to your audience. Before going into technical detail, I would love to spend 1 minute of time to talk about the digital media industry we are in now. We all know the landscape is changing rapidly. The only thing remaining unchanged is to provide compelling content to your audience. People may not only want to sit in the living room to watch content through their TV sets now, but also through all kinds of devices right now carried in your pocket. It could be a phone, tablet, or PC. During keynote in day one, I believe HoloLens even give us a more challenging future that the TV set can be any size when you resizing it using HoloLens. However, being able to deliver such a complicated solution is never easy. Given the proliferation of devices per file, the fragmentation of streaming protocol, and all kinds of network conditions, 3G, 4G, Wi-Fi, being able to build such solution, it's not that easy for content provider, especially as Martin mentioned for live events. In order to deal with the peak traffic, you have to involve huge capital investment upfront, and the event may not even be successful at the end. So as I said, we feel maybe a cloud solution could be very helpful in this case to hide the complexity from content owners or media companies who want to build a solution so that you can focus on your key strengths to deliver better content to your audience. And that's why we introduced the Azure Media Services about 4 years ago to provide a very highly customizable media workflow, video on demand or live, that deliver from the cloud. Azure Media Services is a platform as a service that we build on top of the capability of Azure platform. We leverage on the cloud storage and VM power of the platform itself, that we allows developer to interact with the service programmatically through REST API. And we allows you to do customizable media workflow, starting from bringing your media into the cloud storage, transcode it into certain format, putting content protection if necessary with AES or DRM, make it available for streaming. The first part of the presentation, we will focus on typical video on demand workflow, how you can do that. Usually the first step is to ingest content, that you bring the content to us, and we store your video content in blob storage in the virtual format of asset. And usually with one asset, there will be a bunch of asset files associated with asset. However, bringing large amount of mezzanine file is not a trivial job. we allows you to pre-encrypt the file before uploading using AES 256 through HTTPS, so the integrity of the file are protected during the transmission. And if you want something faster, we do have option of HTTP upload, or even install Aspera client, that's our partner. You can do UDP upload for your file. And we often have customers who have huge amount of mezzanine library that we introduce a new feature allows you to attach multiple storage accounts to one single media services account to easily manage your video content. And the second step, once the file is in the system, we will allow you to command a encoder processor to do encoding job for you. And after the job is done, we put it back into Azure Blob storage. And we provide a model called shared encoding pool that imagine you're sharing a pool of resources with other customers. So you might expect to wait if other customers' job get ahead of you. So what if I don't want to wait? There is an option for you that we call it encoding reserve unit you can purchase. And if I have 3 encoding reserve units, I'm having 3 dedicated encoding box running encoding job for only my, my video assets. And we have added a new encoder called Azure Premium Encoder. So right now we have 2 encoders in the system. One is Azure Media Encoder, and the other one is Premium Encoder. And the combination of these 2 could take broadcast or studio quality video formats. One of the highlights is we added support such as MVF, DVC Pro, and also encoding into up to 4K. And HEVC H.265 is something on the roadmap. And you only pay for what you use, and we charge per output gigabytes for your video file. And you could easily manage through Azure Portal, API, or Explorer tool, which I will be demonstrating later. So for the multiple options of encoding that's pretty new that we are given to you, you could firstly choose the encoding capability based on your input or output file formats. We have encoder, as I mentioned, and also Azure Premium Encoder, both starting at 1.99 per gigabyte. It's a waterfall price that the higher you go, the cheaper it gets. And for Premium Encoder, it's currently in preview, so you might expect the price to increase once it hits GA. And it takes different encoding formats, which you can check on the reference on MSDN on exactly what it supports. And also you can choose your encoding reserve unit which controls how fast the encoder job is running. It started from a basic skill, which charged at $69 per month, up to premium skill that charged at $399 per month, which is a higher CPU capability machine, runs 4 to 5 faster than a basic skill. But of course, you can use share the pool that you don't pay anything, but you don't have a SLA on the job processing time. And after the file gets encoded, the last mile is to deliver it, that we provide a managed streaming service. What it means is we give you guaranteed bandwidth that you can have reserved streaming unit, guaranteed bandwidth starting from 200 megabytes per second, and it just works. You don't have to manage the VM. We manage it for you, make sure it has auto recovery, redundancy, and failover built in. And that's the typical media workflow, how it works from end to end. And I'm going to show you guys a demo using the portal. So right now, I'm looking at a media services account. In Azure Portal, you can quickly set up one yourself as well, attach it with a region. We are currently available in 8 data centers worldwide, and we are landing in Brazil and India as well, and associate it with a storage account. So I'm not going to do this on stage. Instead, I will use an existing media services account. And I already have a bunch of content available. The first thing I would do is to encode the media file. And you can see we give you option of media encoder and encoder premium. And let's choose media encoder, and we are doing a adaptive bitrate 720p encoding. And let's give it a more friendly name. And click on OK. So now what happened is there will be a media processor in the cloud to pick up the job and running encoding for you. And one thing I want to highlight is in the portal under encoding tab, that's how you could choose your encoding skill from basic to premium, and also the encoding unit. You can have 10 box or 100 machines spin up right for you to finish a large amount of encoding job. Okay, and while waiting for this to be done so that we can publish the asset, I'm going to shifting back to the slide to talk about a feature which is also a feature we feel make us competitive in the market. It's called dynamic packaging. Allows you to reuse your encoded content and bring it to various streaming formats. Before talking about dynamic packaging, I have to talk about how things are done in the traditional way. Traditional packaging, that you have a video source and you encode it into an adaptive bitrate MP4. And after that, if you want to deliver it from, to multiple streaming formats, you have to statically package them and store them in multiple copies and deliver it out to multiple platforms and devices. Versus for dynamic packaging, here is how things are done. You still have the video source encoded into adaptive bitrate MP4, and after that, you are done. Our origin server could dynamically package the content as the streaming formats you want on the fly. We alter the container formats so that it could be used by multiple platforms and devices. And there are two benefits you get from dynamic packaging. The first one is you save the time to package the content. And secondly, is also the most importantly that you save a lot of storage. Because for the first one, you can see you are saving the file into multiple copies because of the container format's different. Versus for the second one, you only save your file once. And that's a great saving for a lot of media companies when you have tons of video assets. And I'm going to show you guys a demo on how to publish the file I was just encoded, and also dynamically package and deliver it out using API. So we have media services REST API for all the platforms for you to interact with the service. And we also have .NET SDK, PHP, Java, Node.js to wrap around the functionality as well. And I'm going to show you guys a demo using .NET SDK. Let me switch back to my machine. And now I'm going to open Visual Studio. So the first thing is a console app using C#, so which I'm going to use .NET SDK. And the first thing you need to do is to install NuGet package by searching string Windows Azure.media services. So you can see that you will be getting two of them. The first one is a wrapper on REST API. And .NET SDK extension is a community contribution to us that provides a lot of helper and utility method, which I highly recommend you to use to get your programming more efficient. And after that, the first thing I'm going to do is to make a connection to my media services. And the way to do it is to create a cloud media context by passing in account name and account key. Where to get the account name and account key is from the portal in the dashboard. There is a manage key. That's how you grab the information. And after that, I'm just going to plug it in my program. So I have my media credentials. And I'm going to hide this region. And after that, I'm going to publish the file that I just encoded. So the first thing I will do is to query the file. So you can see all the video files are operates as an object asset in our platform. And you are interact with context for any operations on the asset. I'm doing a link query here by the asset file's name. So a better query might be the ID. And after that, I'm going to publish the asset for streaming purpose. And you can see I'm not doing a packaging here because I'm going to use dynamic packaging. And the way to publish an asset is to ask for locator. And the locator type here is on-demand origin, which means the asset go through the media server. And I'm publishing this asset name, giving a permission of read and a time span of the duration of the URL, which is 1 year from now. And the last step is to ask for the URL, which is also a method provided in the extension. So based on this asset, I'm getting a smooth streaming URL, a HLS URL, and a mpeg URL. And those are just utility methods to get the file URL rights in the console. So I'll just hit on Start button. What happened in this program is it queries the asset and go ahead and publish the asset in different container formats, smooth streaming, HLS, and mpeg. And you may notice, wait a second, all this locator looks the same. And that's the point of dynamic packaging, that the only way to get different format is just to append a different string at the end of the locator. And if we look at the slide here now, that's essentially the magic syntax you appended on a locator in order to pull different manifests onto your player. So I can show you guys how that looks like. So I am going to copy paste this URL, the smooth streaming one. And I'm going to open IE, which show you guys how the video looks like. Okay, it's a pretty friendly version that you can see my video is multi-bit rate with all the video track. And I have 2 audio track here. And the magic thing is the same URL as I paste it here, I can append a string format equal to M3U8 AAPL and paste it in the browser. And you will see the same video now gets packaged in a different format. And that's a Apple playlist format with a appended string. And if you're a spec nerd like me, you might find it pretty cool. And now we finally get to see the video. Since it is already published through the API, you can see in the portal the file gets published. And that was a file I chose, which is my favorite part of Keynote Day 1. And I hope you enjoy.
He should be able to take his entertainment with him anywhere and remain hands-free as he does it.
Yeah, so all I need to say is follow me. Now wherever I go in my house, my entertainment tags along.
Do you guys want that cool feature? At least I do. And I don't need to share my screen with anyone in the living room. And now the question comes that, well, you tell me about this magic player, the magic dynamic packaging, and I'm supposed to put smooth streaming into a PC-based web player and a HLS URL into an iPhone browser, for instance. So what if there is a player that could magically figure out which magic syntax to be put on different browser player and let the stream to be played on different browser? And that would be great. And that's something we just cooked up 2 weeks ago. It's called Azure Media Player. It is a free-to-use JavaScript-based player that could automatically detect the platform capability. Whether the platform is MSE enabled, is it supports Silverlight or Flash, it does all the fallback for you. And it defaults to open standard where possible and switch to different packaging depends on the platform. And it understands dynamic packaging, this feature from Azure Media Services. So this is what Azure Media Player composed of. First of all, we give you a unified CSS file to control the feel and look of the player. And we have a unified JavaScript API to control the functionality of the player, which composes 4 different video players. The first one is a Dash player that we wrote ourselves, utilize the MSE and EME API from HTML5 to play back Dash streaming, and a Flash player, a Silverlight player and also native HTML5 video tag if the player doesn't even implement MSE or EME. And the JavaScript file's functionality is to firstly detect the platform and device capability, okay? And you will choose the player based on the tag order you define. So by default, this is the tag order. We always prioritize standard, such as dash player. But of course, you can say, I just don't like Silverlight. I'm going to remove this from the tag order. Then Silverlight player will never show on your customer's browser. And it knows how to pick up write streaming URL from VAMs by appending the magic string, as I mentioned just now. And it could play back video on demand, live, and protect the content to all the browsers and devices. Now I'm going to show you guys a demo how to build this from scratch. I am opening a Visual Studio now. You can do it anywhere. It can be a notepad. It's just a simple HTML5, HTML JavaScript file. And the first thing I'm going to do is to put in reference, which we host all the CSS file and JavaScript on the edge. So you don't have to install a reference library. You can just point into this one. And we have a library which shows you what's the latest version. So if I want to get 0.20 beta version, you probably don't want to at the moment. You can just change the version here. And even you can just type latest here, which will always grab the latest library we are available. And after that, I'm going to put in a code snippet for inserting a video. And which you can see this is a video tag with, you can put in the skin, like we provide the default skin, and also some of the style that you can choose as well. And after that, you define the width and height of the player. And data setup is something I put in specifically. So this can be hidden by default if you want to choose a default order. But you can definitely change them if you prefer Silverlight over Flash, for instance. You will always fall back onto Silverlight before Flash. And here is where you put in the video source. And that's where you should put in the smooth streaming URL. So I'm just pasting it from just now the video I published. And this simply says this URL is a smooth streaming file. And lastly, I'm going to put in a logging, which shows you guys that which technology my player is choosing now. So this is my player's technology, and also what kind of stream is going through my player. So you can get some of the logging information as well. And without further say, I'm going to launch the player in Chrome browser. And you can see that Chrome is pretty cool that it supports Dash. This is a Dash streaming player. And it picks up Dash stream as well. And you can see the player is doing the detection. And similarly, I'm going to open this player in Firefox. Is it choose default player? Never, OK. And I'm going to open the website in Firefox. So pop quiz. My Firefox doesn't support a Flash. And you know that Firefox hasn't fully implemented MSE yet. So based on the tag order, which player is going to show up in my Firefox? Anyone? Based on the tag order? Silverlight, yes. I heard. And hopefully a Silverlight will show up. And now you can tell the player really detect the capability of the device. And it fits in the Silverlight player here with a smooth streaming stream. OK. And if you guys think that's not cool enough, there's one more thing I want to show you guys, which I think is very cool. So remember the time, if you want to update your player, you might need to end up doing work on 4 copies of your other players, right? You do a change on HTML5, Silverlight, and a Flash. So the advantage of Azure Media Player is you change at only one place. So I'm going to remove autoplay from my player as a function. And I'm going to add a poser on my player. simple stuff. And I already have a poster image there called future. And we are launching the player now. Let me do a refresh on my Chrome. And you can see a poster appear. And autoplay is removed because I removed that. And if I'm showing it on my Firefox browser, it's a Silverlight player. And you can see the control also changed on Silverlight. And you don't need to code in Silverlight because it's a unified JavaScript and CSS UI that controls all the underlying players. Isn't that cool? No? I thought that was the coolest part of the player because you don't have to code against Flash or Silverlight. And I leave with you guys some of the documentation. It's well documented, all the APIs you can use. And also, we have a player demo page which give you a bunch of players with customization. The best way to learn is to just right-click and view source and check out all the coding details yourself. So I mentioned the first advantage of Azure Media Player, how easy you can maintain it. And here is the second advantage. So if you work in the player technology space, and you may realize how messed up the place is. Look at the metrics here. That's all kinds of browsers, and the technology are best supported on different browsers, devices, and also the streaming protocols. You might start to take a note on this metrics, or you can start using Azure Media Players, which we will keep track on what type of update may come to the next browser. So let's say Safari tomorrow will say they are ditching HLS and supporting npdash, which probably will never happen. But for us, we will get to know that, and we will update the Azure Media Player to fetch npdash stream into a Safari. So you don't need to worry about all of this. And I will leave the slide with you, upcoming features. And there are two I want to highlight, which I think all of you guys care the most. One is analytics. You will get to know what your player are doing, what your customers are doing with the player, and also ads support. Easily to insert ads into the player. And that's two features that we are prioritized and also will be coming very soon. And after that, let's shift in the gear to talk about Azure Media Indexer. So we all know the search right now is pretty much optimized around the text on the internet. If I want to search any information, I just search in text, and you will get me articles in text as well. With vast amount of videos appear online, what if it could be easily searched through video and get a video content you want? It's not that easy, right? Because the internet simply don't understand video that well. And that's why we have announced a new service called Azure Media Indexer, which on board Microsoft Research's years of research results on natural language processing, that we could be able to analyze the video track in your audio track in your video file, and generate a time-aligned transcript for your video. And we support English and Spanish at the moment, which this technology has been used by a lot of companies such as Washington Post, NASA, the Energy of the US Department, to index large amount of video library that they have so that people can search through them to benefit from the value of the videos. So let me show you guys how you can use Azure Media Indexer easily. And I will be using a tool called Azure Media Services Explorer. It's free to download that. I think all of you guys should use this. It's really convenient, which I will pick up a source file. It's very easy to do, to say I want to index asset. And you have given a choice of English or Spanish. We are onboarding more language here. And give it an asset title, and you can just kickstart the indexing job right away. So I'm not going to wait for this indexer job to finish because it takes some time. I want to show you guys what come out of indexer job. So this file, this index result I run before the event, and I can take a look at the information here. It is a container that contains a bunch of files. So one of them is a VTT file, and there is a TTML as well. So let's take a look at this VTT file. So I'm opening this file. It essentially gives me the time-aligned transcript of the video file you just saw. It's pretty short, so you see the recognition is not that high. It's high enough, like almost 0.9 out of 1. And that's the content here, hands-free as he does it. Whenever I go my house, my entertainment tags along. So it's pretty accurate as well. And that was the file you can embed it in the player to show it as a closed caption. And also, we provide the formats in TTML as well, and a index file in binary, which works with SQL Server. And lastly, a keyword XML, which it shows the keywords spoken in the video, such as entertainment, hands-free, house, and all these things. And as Martin showed in one of his demo, that was the player experience you can build, which you just put in the.
So we invented.
Let me pause here. You can put in the web VTT file here, attach it with the player, and it will show along with the player. So that's what I want to show for indexer. And let's move on to a different part of the presentation, which is what if you have premium content, you want to protect the content, what you can do with Azure Media Services. So first of all, we allows you to securely upload your file, and we can securely store your video file as well. You can encrypt the file at rest. And for the streaming side of things, we can dynamically encrypt your content with either AES 128 Clear Key or Microsoft PlayReady DRM. And we provide, say, hosted license for DRM or AES key. And if you use our key service, we build in token authentication module that allows us to authorize the key to your player. And also, if you're using AD as your authentication system, we provide very easy integration to reuse the token that AD issued. And it provides diverse playback option. The player I showed you guys works on protected content as well. So we provide two content protection methods in the system. One is called Microsoft PlayReady DRM, and the other one is called AES Clear Key Encryption. So Microsoft PlayReady is one of the well-known DRM technology in the industry that allows you to encrypt smooth streaming content with PlayReady protection via we do CENC schema in the system, and you can package it into HLS or MPEG-Dash. PlayReady technology is really designed for media business that it allows you to define very comprehensive media rules to restrict the access for video content. You can say the video can only be played back in the next 24 hours, or if my audience bought the content, they can only watch it on laptop but not streaming through HDMI. You can do such a grand restriction on your media content. And one thing very importantly that the decryption of the license, which is the key, and also the content is happening in the protected memory, which means neither the key or the clear content are ever exposed on your client devices. Therefore, DRM technology is the ultimate prevention for piracy, which means once Game of Thrones leaked on BitTorrent, that's direct revenue loss on the studio. And that's why all the studios for premium content, they would require DRM protection. That's critical for the media business. Versus for AES Clear Key Encryption, it's a lighter encryption that we introduce. It still do over-the-wire communication that we do AES 128 for the encryption. However, the AES key is considered stored in clear on your client device. So you have to trust your client in order to use AES. One of the examples is I work in Microsoft, so according to Microsoft agreement, I'm not allowed to distribute my training video. Therefore, AES is probably a good solution for enterprise because you should trust your employee. And in that case, the video stream is actually protected over the wire from man-in-the-middle attack. So that's pretty efficient. In terms of how to choose each feature is really, at the end of the day, based on the needs of your business. And here is how we do dynamic encryption with AES and PlayReady. And as one of the very few providers in the industry that does this, you have a video content and store it with us and transcode it into adaptive bitrate MP4. And after that, you will define the following, which is on the asset, you tell us what type of key you want us to use to encrypt your content, and an authorization policy. How do you want us to authorize the key to your player? You can say, I want token authentication. If the player gives me the right token, then I will issue the key to the player. And also the PlayReady license template is also embedded in the authorization policy. And also you need to tell us which protocol you want us to apply the encryption upon. You can say I want to do AES with HLS protocol and do a PlayReady encryption on smooth streaming. You can define that in asset delivery policy. And after that, that's an old configuration. You're not doing any encryption yet. Our streaming endpoint will dynamically encrypt the stream and package it on the fly, deliver it to all the client and devices. After that, your client get the encrypted stream. You got to have the key to decrypt the stream, right? And that's usually happens you log in with your own authentication system. It can be a Netflix user's subscription database. And once the customer log in, they will get a token, which they could request license or key to us along with, and we will look at the token and say, okay, the token is correct. We'll give the player the key. And with the key, the player now can decrypt the content and play it back on the device. There are two things I want to mention. First of all, the encrypted content is delivered through HTTP so that you can attach a CDN in between of streaming endpoint and the device. It works fine because it's HTTP. And the key exchange happens on HTTPS, which is a secure communication channel, which means your key and the license will never get exposed over the wire. And one of the great things about dynamic encryption is, in the old days, if your key gets leaked, what are you going to do? You have to decrypt your content and re-encrypt it again to put up online. But for now, it's a simple configuration change. I'm just going to change my content key, and the streaming server will pick up the new key and deliver the encrypted content right away. And one of the biggest problems when we roll the service is people don't understand the token. So I want to add 2 slides here to tell you guys how to compose a token. We support 2 token formats, Simple Web Token and JSON Web Token. JSON Web Token is one of the widely used token formats in the industry that it can be generated by anyone. You can use any library to generate a JSON Web Token. And it composed of issuer, audience, not before, and expiration time. And you can sign the token using symmetric key or asymmetric key, which is a X.509 cert. And issuer represents who issued the token. And the audience is your player domain, basically. And not before, and the expiration is when, for how long you want the token to be valid. And the token looks like this. It's a XML or JSON file. And you can sign the token, which means you're doing a HMAC or RSA to sign the token with your symmetric key or asymmetric key. And you send us the token and the signature so we know how to verify you. And one question would be, if I want to issue a token for the player to retrieve a key, will I want the token to be short-lived or long-lived? Anyone? Short-lived, right? Because I don't want people to keep using the token and getting key and they pass the token along, right? And for the token workflow, that you have a player And you need to build a backend to actually authenticate your player and give back a signed JSON token. And once the player gets the token, the player knows how to use the token to request key from us. You just send the token to us through either authentication header or a parameter string appended on the URL, and we will return the key to the player, and then the player can play back the content. So let's go through a demo that if you guys get lost, you can try to understand it through the demo. And I hope I didn't lose all of you guys. So we'll use the Azure Media Services Explorer tool. The first thing you need to do is to unpublish the content. Reason being, once you attach a key to the player, it will be a new streaming locator generator because the cache is going to break anyway. So, and after that, you can say, I want to add the dynamic encryption and the key delivery policy for this asset. So we're going to launch this function, and I'm going to do a player-ready common encryption. And I choose the delivery protocol that I want to enable the encryption. If I uncheck HLS, then HLS will be blocked for streaming a clear content. And click on next, that it will ask you to either you can let us randomly generate a key for you, or you can give us a key by giving us key ID, content key, or key seed. And the next one is to configure token authentication, which we give you the option to do simple web token, JSON web token with symmetric key, and JSON web token with asymmetric key. So I'm going to do a symmetric key JSON web token and set a token property, issuer and audience. And after that, I'm giving the authorization policy and name. And here is where you can define the play-ready template. You can do persistent license or non-persistent license, and also a bunch of advanced settings, whether it is allowed through HDMI port and all these things. And we give you I think this is like 100-page files that a play-ready team has for the template. You know how complicated you can define with DRM. And after that, you're done. So the system is going to do the configuration to let us encrypt the file on your behalf. And now the next step is to create a locator. So I'm going to publish this asset, create locator, and give it an expiration date, like say a year from now, for instance. And the file now it's encrypted with dynamic encryption, CNC, and it is published. That we'll get a streaming locator here, which you can see from the file information. I have the asset file here, and I have content key that attached to this file. And also I have delivery policy, the authorization policy that I did the token configuration here. All the information you can backtrack from this tool. And now I'm going to play this file using Azure Media Player. The great thing about Azure Media Services Explorer is it simulates the process of your token issuer service to issue a token to the player. It says create a test token. And I will say, OK, give it expiration time, like 5 minutes later, and open this test token, open this player. And now, let me mute myself. You can see that it is a smooth streaming content that playback via Silverlight with PlayReady because I'm using Chrome now. So if I bring this manifest, open it up, I'll show you guys why this is protected. So look at the manifest. Everything is the same except there is a protection header here. It's a base 64 encoded binary which can be read by the PlayReady SDK. It's a license URL if I decode it and with the license ID. That's how the license information gets carried in the manifest. And if I would copy-paste this URL and launch it in IE, because IE implement the EME with PlayReady support, and now you can see that a Dash player is playing back, a JavaScript player is playing back PlayReady protected content, which I think that's really a great implementation that the IE team did. So I said I want to conclude my content protection session, part of the session, which you can use it easily to do with Azure Explorer tool. You can do it with API too. It's a pretty complicated and hard area that I hope you guys get a general idea of how to do it through this demo. And we'll move on to the most exciting part of the session and also the most risky part of the session. That we're going to talk about live encoding and streaming, how you can make it working. And the first thing you do in the system is to create something we call live channel. So imagine this is like a box we spin off for you to receive live stream. And we expose ingest URL, allows you to push the live stream in. And you will have an input device or an on-premises encoder that push content into us through RTP, RTMP, or smooth streaming. And one of the features that we introduced is called live encoder, which allows this ingest point to forward a single bit rate stream, and we are going to encode it into multi-bit rate. And that's the function of live encoding, and which is never available from 2 weeks ago. And after that, the stream is forwarded to preview module. And preview is going to expose a preview URL, which allows you to inspect the health of the stream. And also for a soccer game, for instance, all the commentary are done via watching preview URL, and they're sending the audio track in again. And the preview URL is afterwards forwarding the live stream into program. Because nothing is actually saved through preview module. The program module is what makes the live stream persist in your storage. And you will convert the data into fragmented MP4 and write into blob storage for DVR functionality. You can have a live stream with several hours of DVR window. And after that, the streaming endpoint will pick up the stream and doing dynamic encryption or dynamic packaging just like the vault stream. And after that, it gets delivered through the CDN. And there is a program URL you use eventually to embed in the player to play back live stream. And one of the great things about live encoding is really about before, without this module, if you want a multi-bit rate stream, your device or on-premises encoder has to encode firstly, right? It's a pretty CPU-intensive activity, which means you need a higher capability machine. But now, since the encoding is shifting to the cloud, a lot of devices can do this now because it doesn't require high CPU. And another advantage is that it saves you bandwidth. Before, you are sending a multi-bit rate stream, and now you're only sending the highest bit rate of your stream and let the cloud do the heavy lifting work. And that's really the benefit live streaming gives to you. And we expose a REST API, of course, allows you to programmatically interact with the service. And if you want to do dynamic encryption, very quickly, I will show you the architecture that you send the stream into channel or program, and the archive into the storage. And after that, we do everything the same. You configure content key, the authorization policy, and delivery policy on the asset. The streaming endpoint will dynamically encrypt your live stream on the fly and send to the player. And the player is going to talk to your authentication system, obtain the token, and use the token to obtain the key and get a stream playback. If you follow me for the first part of the presentation, you may find this architecture very easy to understand. It's the same as VOD. And now let's move on to the most exciting part, the demo. Okay, that is right. So firstly, let's navigate to Channel tab. We can add a new live channel, and let's say test channel. What a great name. And there is a new thing coming out called encoding tab, and you can choose standard. And after that, it allows you to choose ingest protocol, and let's choose RTMP for now. And it also has something new called add signaling. So I can say, yes, let me do add signaling. And I will show you guys what it does later in the demo. And I can choose a slate, which means we can send a slate into the stream and encode with this image. Let's say if there's a break time of the session, you can do that. And after that, it gives you a encoding preset for your live encoding. So for now, we do a default 720p encoding. You can see there are 7 layers here from a high profile to baseline, and with different bit rate. And of course, we will allow you to define your own encoding preset later when the service is publicly available. And after that, I will set an ingest restriction. You can restrict it to your current IP and start a live channel now, okay? And the whole thing takes a few minutes, so I will use one which I pre-configured. It's a live encoding channel. And there are 2 ingest URL now. That's an improvement we just did last month. Because you know, sometimes when the VM gets restarted, the ingest URL may get disconnected. And that's why we give you a backup URL, which you can also put into your encoder in case one failed, the other one can continually ingest stream. That's very, very useful for a lot of broadcasters. And I'm going to grab the input URL and starting a tool called Wirecast. This is one of our partner solutions, which could send a stream into the cloud. And I'm choosing Azure Media Services profile here, and click on OK, and paste in the ingest URL here. And I actually customized the profile a little bit, which I will show you guys. That we allow mean concept HL264. As someone asked for the golf line just now, it was a 60 frames as the key frames, and also time code ever 30 frames. And after that, click on Save, and click on OK. And I'm going to live stream myself. Added a camera here. One thing I want to let you guys know is I'm actually encoding to only 1 bit rate, is 720p. Okay, I'm only sending a single bit rate stream, and click on Stream. So now the stream is sending over the wire, and you can see that I'm having a pretty high CPU. Oh, okay, it drops down. That's good. It's correlated to whether the demo will succeed. And then the stream is going through the live channel, and we can see it through the preview URL. And now, hopefully, this will get played. So this is a good sign because it's telling me my channel doesn't have enough data chunk yet. So we will start playing when you have like more than 10 data chunk. So I can start it again, and we should see the video shows up here. OK, good, great. And my laptop is getting challenged by the bandwidth here because I'm uploading and downloading at the same time. And one of the magic things I want to show you guys is the preview URL if I open it up. Remember, I only encode my video into 720p. But if I open it up here, you see all the bitrate appear because the live encoding simply encode the file into multi-bit rate. And I think that's a great thing, that you're shifting that heavy lifting work into the cloud, and it's very useful. And after that, I'm going to go in and create a program to archive my live stream. And I can say this is a clear program with 4 hours DVR, and publish the program. So now the live stream will be writing into storage. And at the same time, I can say, I want another program. I want to encrypt the program so others don't see it. I can say I want an AES encryptor program. I can just do it right away. And another program spin off with encryption. And it's creating the program now. So now if I start this clear program, I could be able to see the stream running. So I'm going to use the Azure Player demo site Martin mentioned. And now you can see the program is running. Please load the player. Oh, I can try it here as well. So that you should see the stream now is getting stored, which, let me check my encoder. Yeah, so you see that's the problem. When it doesn't get played, it means I lose connections, that because of the bandwidth issue, that the stream is not getting pushed into the cloud. So it happens in live demo like this, but you guys get the point, right? So unfortunately, but that's a great tool, it actually tells me there's something wrong with the encryption, the uploading of the content. Which, let me switch back to, that's a bad frame, okay. Let's switch back to the slides. But at least I showed you the first part of the demo, which you can live encode the stream. And if my Wirecast could, the bandwidth works, then you can see the stream gets archived into the cloud as well. And I want to recap in terms of features that allows you to live encoding a single bit rate into adaptive bit rates. We take RTP. You can send MPEG transport stream, RTP, smooth streaming as ingest protocol. And there's one thing I couldn't show you guys was the add signaling, that I can actually allows the channel to send a slate, so that the slate actually gets encoded along with the stream, and also get a thumbnail preview of the live feed. And we do dynamic packaging of the live stream into HLS, MPEG-dash, smooth streaming HDS, and also dynamically encrypt the stream. I'm just trying it again with my, it doesn't seem the internet is picking up here. Yeah, so, well, what a pity. I think I spent the most amount of time on this demo. I want to give you guys a key takeaway that media services are very easy, flexible, and powerful to use. And we want you guys to really forget about all the complexity, the fragmentation of streaming protocol, that we have the player allows your customer to watch the content on any device and using any protocol. And pay what you use, we'll have very easy understanding billing. And ultimately, we want you to deliver your media on any device and delivered in the cloud. So as said, I leave you guys with some of the resources which you can check on the information. And also the resources you can check on the information about Azure platform. And also we have 200 free credit if you want to get started and try out Azure Media Services. For us, the developer, the best way to learn is to get your hand dirty and try out all these things. And also the eval. As said, I will end my presentation here. And thank you so much for your time. And I hope you had a great Build conference. Thank you. And we can take question now. So I didn't mention, actually, the add slate. You guys in the back can slot in the add slate for me when my demo falls. Edit it for the post-session video. Any questions? Yeah, sure, go ahead. So that's a good question. For AES, the answer is yes. For HLS, it was natively supported on Android and iPhone. For PlayReady protected content, for Android and iOS, you will need to build the app using PlayReady client SDK, which is owned by the PlayReady team. There is no web player that can play PlayReady encrypted content on the player. AES, yes. AES was natively supported by HLS or Android. That if you want to build a native app, you can use iOS SDK. It just works from the SDK itself. And if you're using the web, the browser itself supports AES decryption. Yes, it was in the decryption. It happens within the browser implementation on the phone itself. Yeah, it was a supported encryption formats. Yeah, you don't need anything extra. And for Android, it's the same. Yeah. Yes, so as I said, analytics is one of the things that coming on Azure Media Player, and that was one of the tracking events that you can easily get from the player. So we can send you the analytics. You can define how often you want the player to send all these behaviors to your backend service, and then you can analyze the log afterwards. Yeah, it doesn't have it right now on the player, but that was part of the analytics framework that I was mentioning, which is coming soon. Yeah. So for whoever stayed, actually, I want to try this. This might work. Which you see, I'm doing Q&A. I really hate this angle, but that's fine. You can insert an add and slate. Okay. So we are sending a SCSI-35 signal into the manifest. It shows the QID and also the duration. So which would show like in a few seconds, which should replace here. Let me check my stream is working. Yeah, it's a live stream. So it gets buffered here. The network is, yeah, so you can see I was doing, there's a certain delay here from the preview URL, but you will show up later. And the difference between insert ads and slate versus insert add is, yeah, so I had a slate prepared, which you will show about 30 seconds. And imagine my demo failed the moment the gentleman over there can insert a slate, and so people don't see the failed moment, or it could be a break time, right? You're doing some other things, and then you just insert an advertisement. So the only thing we don't do now for the moment is to insert a video. So your player need to listen to the SCSI-35 signal on the player itself and replace it with a video, and that's how you can stitch the ads. You can see the slate disappeared because I only said insert the ad signal for 30 seconds. So that was actually built into the player itself, which we only send the signal into the live stream. Yeah. Sorry? Oh yes, yes. It's you can check it online. It's open source, and you can customize the player as well. Yeah. Yeah. Yes. You see, that's the thing. The demo only works after the session ends. It's like magically. The Wi-Fi only go down when you do the real demo. Yeah. Yes, yes. But I don't want the live to fail anyway. Any other questions? Yes, yes. So we only support audio through Dash, which you only have a Dash streaming with the audio track, but we don't do audio streaming that much for the moment. We mainly focus on video, yeah. We do have a lot of customers that request audio, so we might add a capability later, yeah. Any other questions? Okay, cool. Thank you so much.